Hello everybody! In this lesson, we'll be covering projectile motion. Projectile motion is the motion of an object thrown into the air, where the only force acting on it is gravity. We'll assume there's no air resistance. We analyze projectile motion by breaking it down into two independent components, the x component and the y component, or the horizontal component and the vertical component. These happen simultaneously but are treated separately. Horizontally, the object moves at a constant velocity, so the acceleration in the x is equal to 0. However, in the y, it's a little different. Vertically, the object will be accelerated downwards at negative 9.8 meters per second squared because of gravity. Together, the motion of the x and the motion of the y produce a curved path, a parabola. At every point, the horizontal and vertical motions combine to define the object's total velocity. In the horizontal direction, distance equals speed times time. Since there's no acceleration, velocity stays constant. So displacement equals the x component of the initial velocity times time. In the y, it's a little different, and we have to use simple kinematic equations where acceleration equals 9.8 meters per second squared. These equations describe position, velocity, and time under constant acceleration. For example, this one, we can use it to find the height of the object when we're given the initial velocity and the acceleration and the time that it's on its path. And this one, we can use it to simply find velocity in the y direction when we're given the initial velocity in the y direction. And then this one doesn't include time, so this is very useful in solving many equations. So now how do we find the x component and the y component of the initial velocity? It's super important in a lot of these equations. So we have an object launched at some velocity let's call it u, at an angle of theta. To find the components of the velocity, we can use SOHCAHTOA. So if you recall, sine theta equals the opposite side over the hypotenuse, and cos theta equals the adjacent side of the hypotenuse. So by opposite and adjacent, it means this side, which is right next to the angle, and this side, which is opposite of the angle. So if we want to find the horizontal component or the x component, we simply find the part of the triangle that's horizontal. So this part is horizontal, so clearly we have to use cos theta. So ux equals u cos theta. And it's the same thing with the y, except with this side. So the y component of the initial velocity is u sine theta. Now that we have a bridge between the x and the y, we can derive many important formula. There are 3 of these important formula. These assume that there's symmetry in the way that the object is launched, so that it will land at the same height that it started. So this first one is the formula for range. This one is the formula for max height, and this one's the formula for time of flight. Now, using the time of flight formula, can you derive the formula for max horizontal range? Of course we can. Let's get to it. Recall x equals ux t. We have t right here, and ux is just simply u cos theta. So let's put that all together. R equals u cos theta times u 2u sine theta over g, and we have r equals u squared 2 sine theta cos theta all over g. R equals u squared sine 2 theta. We get this over g. We get this because 2 sine theta cos theta equals sine 2 theta. The full proof for all of these is left as an exercise to the viewer. If you want to put your proof in the comments, I'll go through and check it. And if you have any questions, also put those in the comments. I'll also answer them to the best of my ability. Thank you for your time. Have a great day.